Hello, good morning, good evening, good afternoon. Welcome to my session on Azure Synapse and the designing of tables in Azure Synapse. My name is Armando Lacerda. I'm 2 minutes off. My browser had an issue here and I had to restart the session. So hopefully everything is working just fine now. Let me just double check here on another tab that I have everything going on. Everything is running smoothly. 1 second. So we are using this platform to stream out the session to you. And through this platform, there is no two-way talking, right? So I'm going to be presenting here. And if you have questions after this presentation, you're welcome to come and connect with me on LinkedIn or Twitter, right? One of the two platforms. So I think we are all set. So let's get started. My official good morning, good evening, good afternoon. Welcome to my Synapse session. My name is Armando Lacerda, and I hope you are enjoying the IT Pro conference, the IT Pro Dev Connections put together for our friends there in Greece. I'm connecting here from California in the United States, so it's very early here in the morning. It's still dark outside, but I'm very happy to be here with you this morning. A couple of introductions before we get into the subjects. So again, my name is Armando Lacerda. I am a senior cloud data platform architect. I work with a company here in Georgia, in another state here in the United States. The company's name is Wintellect, and it's a consulting and training company. I'm particularly involved in the projects that are associated with the data platform in Azure. I work with databases. I've been working with databases for over 30 years. I first started with mainframe databases in SQL DS from IBM. Then I moved into Oracle, and late 90s, I got introduced to SQL Server, and there was the promise of SQL Server 7.0. I started working with SQL Server 6.5 and then SQL Server 7.0. And I got seduced by the dark side of the force and moved into the SQL family of products and never left. So I've been working with SQL Server for almost 30 years. And I cannot actually remember the last time I have worked on a project that's just on premises. I have been working with SQL Server in the cloud and the BI platform, the data warehouse and BI platform in the cloud. Solid for the last 5 years. And I also have some Microsoft certifications. I'm a kind of certification junkie. I like to take these exams because one of the things I do is I teach. I love teaching. I love training. I'm a Microsoft certified trainer for about 30 years too. And in order to train an official class from Microsoft, you have to have the certification associated with that topic you want to teach on. And therefore, I've been collecting a lot of certifications throughout the years, not just to be able to teach the topic, but also to validate my knowledge, my skills on the actual product. I'm also a Microsoft MVP, which stands for Microsoft Most Valuable Professional, which is an award that Microsoft gives to people who does things like this, get involved into a conference and share what they know about the Microsoft products. And if you get noticed and you get nominated, Microsoft may award you the MVP title, which is pretty cool. It comes with a lot of perks associated to it. And if you are watching this presentation, make sure you connect with me through LinkedIn or Twitter. I don't tweet much, but usually when I do, it's about technology news, something that's going on in the cloud space. LinkedIn, I do post a lot in there, and manage some groups in there. Facebook's more for personal stuff, so if you want to connect Facebook, it's fine, but you're going to see other content that is not just technical. All right, so that's a little bit about me. Let's move on and dive into our subject of the day, which is the Synapse as a whole, and specifically inside Synapse, when to use a particular type of tables of the many tables that exist in Synapse. So to get, before we get there, a shout out to the sponsors. Events like this never happen without the sponsorship, without companies, backing it up and make sure that we have all the infrastructure that's needed for the event to happen. And of course, all the volunteers and the people coordinating the event. So don't forget to take a look in the lobby and go around the environment and check out the products that the sponsors are presenting and bringing up here to the conference. All right, so Synapse. What is Synapse? In the past, if you're not familiar with Synapse, if that's the first time you're hearing about this service offered by Microsoft, only in the cloud, so it only exists in Azure. Synapse comes from a line of products, a family of products that are focused on data warehousing. So the idea that what it came from is from data warehousing, not really big data, but data warehousing. But now it also encompasses, it gathers big data around it as well. So what is it? So before it was Synapse, it was called Azure SQL Data Warehouse, Azure SQL Data Warehouse. And in Azure SQL Data Warehouse, the only engine that was in there was the relational engine. But in Synapse, we have way more than just the relational engine that was there before. Actually, Synapse is a collection of services bundled together in one environment in order for data engineers and data architects to create pipelines able to process data from start to finish, and with minimal amount of time and minimal amount of management effort, so we can get all the way to the end to time to deliver to our RTM as soon as possible in a very streamlined way. And that's important to keep in mind, because when we talk about the tables we can have in Synapse, you need to understand which environment inside Synapse we are referring to. So, for instance, I got here this simple design, which would be a simple pipeline, right? A simple design for a pipeline running in a cloud. So, let's say you are working with IoT data here on this diagram. I use IoT Central and Event Hub. There are usually two Azure services that listen to IoT devices and stream those data into the cloud for processing. And when we process data from data streams like IoT devices or IoT systems, you can either do a stream processing or batch processing. So let's say this one here, we're doing a batch processing. These services are reading this data and they are dumping this data into a data lake. Data could also be coming from other databases, other systems, we could have a website, and this website is collecting data from people browsing the website, or perhaps even the sales that may happen through the website. So all of that data is being collected into a Cosmos DB, and from time to time you want to push that data from Cosmos DB into your analytical pipeline. So this is a very simple collection of services here. So the data lands in a lake someplace, and from the lake, data scientists could be using Databricks to process that data in the lake, and from there going into the data warehouse. In the past, right, it used to be called Azure SQL Data Warehouse. Now we call it Synapse Analytics. But like I mentioned before, the Synapse Analytics or the Synapse environment, the whole environment, is not just that engine, the relational engine anymore. It's actually an environment that gathers together all of these services that I have just outlined in there, which means that when we spin up Azure Synapse, we will get equivalent services inside Synapse Synapse that will run everything that's being highlighted in there. Power BI will be there, for instance, not for the final visualization for people to, for your clients to consume from, but actually as a tool for designing. So you can design your visualizations and then deploy to their Power BI subscriptions, to the production Power BI subscriptions. But Power BI is there into the environment. We have the relational engine, and we also have the equivalent that would be of a big data processing that would be, in this case here, Databricks. Within Synapse, though, some names change because the actual service, the bits, the binary behind the services they are different. In a regular deployment and a traditional design, you would be using Databricks, which is a specific, specialized version of Spark, Apache Spark. So inside Synapse, Microsoft decided not to use Databricks as the product itself, but to actually use fork the open source Apache Spark code and re-implement it inside Synapse. So that's one of the things in there, right? If you have something done in Databricks, if there is something specific in your code in Databricks, you could not bring it straight into Synapse. But the point here is, without getting much out of our relational focus in here, the point here is we do have the Databricks, the big data support in there, right? For, Python and Scala, we can do all those things through Apache Spark over there. And what would be the data transformation element would be, data factory outside Synapse. Inside Synapse, it becomes the pipeline. In summary, so you can get the global overview inside Synapse and then focus on the table types and how they affect your design inside Synapse. Make sure you get that we have the transformation pipelines, we have Apache Spark and you can create clusters of this Apache Spark to work with regular data from the lake, unformatted, not tabular data sources from the lake. And we have Synapse Analytics, which is our relational engine. Another thing that changes inside Synapse when you deploy the Synapse, which, by the way, came GA, this final version we're discussing here came GA just about 2 weeks ago. So now it's official. You can use this for production on this environment we're talking about. But again, when we get here into the Synapse Analytics, one of the things to keep in mind is that you have this is your relational engine, is your data warehouse engine, and you have two services, two possible service or type of services inside Synapse Analytics. So let me show you that. Let me show you that in the portal. Let me open here a new browser, and let's take a look on that together. Let's go to Azure. And please do not email me on that Hotmail account. That Hotmail account is just my Microsoft ID that I connect to the portal for these demonstrations. Microsoft give us some credits so we can demonstrate these things on conferences like this. I never read any email that gets in there. Everything goes straight to trash, anything that lands in there, all right? So please do not email me on that account. All right, so here, see, I have created a Synapse workspace here using a simple data that comes from the New York City, the service in New York City that controls, that regulates the taxes and the limos and for rent, like Uber and these things. So this data is available there. If you follow this link here, you can see that Microsoft has prepared the data, so you can use the data as an example yourself if you want to try these things later. But here I'm in the portal. We just got into the service, the Synapse workspace. But this is not actually Synapse yet, right? This is just the management of Synapse. There is some environment elements going on in here, not what we're looking for in this session. So I'm going to go straight and connect to the Synapse Studio or the Synapse workspace. See, it's Workspace Web or Synapse Studio. They're both the same. So when I click there, a new tab pops up, and I will get into the workspace. And this is the entire environment, right? We're browsing the environment so you can understand the differences between this and SQL Server. Like if you're already working with Azure SQL database and you're like, going to use Synapse because, they're both based on SQL. Behind Synapse, we have SQL Server in there. So they got to look the same and work the same, right? And I'm hoping at this point in this session, you're having the feeling that Synapse works very different from SQL Server, right? It's a very different environment, way more comprehensive than SQL Server itself. So here on the side panel here, we can see the hubs where we can control these elements, right? We can control each one of those elements. So this is the pipeline I mentioned before. This is for monitoring, and this is where the data engine is where we can work with the data. So when I click in here, I see that I have two databases that I have already created based on that New York tax cab information from the sample source. So I have two of them already in here. I could have a third one actually if I go back here into the workspace. If you may notice in here, this one is working. Let me see. Zoom it. I forgot to turn this guy on. So let me turn this guy on. There we go. Let's zoom in. There we go. So I hope you have noticed here on the top on the center, right top center of the screen, that we can add dedicated SQL pools and the Apache Spark, right? So I have not added any Apache Spark onto my environment yet. So if I browse down here, you can see I have no Apache Spark, but I have two database engines, right? Two SQL Server database engines. And I should not say SQL Server, I should say regular tabular engines, because it's actually Synapse running behind the scenes. So the first thing you have to notice, and that's specific for Synapse, Azure SQL Data House was not like that. The first thing you have to notice is that when you are designing your tables, you have to understand that some of the tables will only exist for the dedicated Synapse Analytics SQL Pool, right? Only for this one here, right? For the dedicated. The serverless one is a particular type of SQL Pool. And by SQL here is in supporting T-SQL and all of that. There's a particular type of SQL engine service offering that does not have a database. It's called serverless. It's weird because we usually call it like in my mind what I have is the computing without storage. The storage is really not associated with the computing. And if I go back here to the diagram, the storage is actually in the lake, right? So for the serverless, what you're really getting there is the information that is stored in the lake. So when you go into the storage, and if I go back in here, go back here in the portal and look into the storage for the SQL Pool, you can see here that the only kind of tables that there are in here are external tables. So here we go. Not every table is the same kind of table. A table is not just a table. In this particular case here, when you go to the serverless one, you can only have external tables. So when I open here this environment, I see I have one table that's pointing out to a data lake. And when I do queries in this table here, like if I ask SQL Server to come up, if I ask the Synapse Studio to come up and give me a query, when I run this query, what's happening behind the scenes is there is a pool of Synapse engines based on SQL Server that will run and go against the data that's in this data lake and process it. We collect the data from the data lake, process the data, and give me the results. So when I run a query like this, it's really external data coming from coming from the lake and whoever is putting data there in the lake. And if I go out in my subscription here on New York Stack, this is the storage account where the data lake was created. So this is the actual data lake. And if I go here into the data lake, I can see that the files that query is querying is collecting information from, they are writing here into this file system. So here the partitions for that file system, and here the Parquet files that this guy here is collecting information from. So this is a very interesting model, and usually it's very valuable for data scientists and for people who are like, let me probe the data, let me see how the data looks like in its raw format. I do have to have some kind of a schema created on top of the unformatted data coming from the sources, right? In this case, Parquet files. And so I do have to have some schema going there. But the beauty of this is I can do regular select statements on top of those external tables, which is fine, which is great. And the other thing that's interesting about this one here, this offering, is you are charged by the amount of data you process. So if this particular query here, if this query runs through, 50 gigabytes of data, I'll be billed by it's $5 US dollars per terabyte, depending on the region I'm working on. But it's about $5 per terabyte of data. So if I run 100 gigabytes in here, I'll be charged 50 cents of a dollar, right, on this query. So, to explore data, it's a very, on its regular way, in this natural raw format, it's a very interesting way that Azure Synapse offers to us. So this is the one. I just want to mention this one here because some people get confused about the offers that are in there. And the focus of this session was to show you the tables, and the table is not just a table, there is more into a table. So this is kind of a side note of some types of tables we have, which is, in this case, the external table. That's usually very valuable on the serverless, what the portal presents to you as serverless. If I go back there to, go back here to the portal. You can see here as serverless. You can see also this designation here sometimes instead of serverless. You can see also it being referred to as on-demand. But the one I really want to focus on is this one here, the dedicated one, which is the more expensive one, by the way. So the dedicated one, it's actually what really compares to what Azure Data Warehouse is, SQL Data Warehouse is used to be. So if you have seen Azure SQL Data Warehouse before, this particular portion of all of the services I have shown you in Synapse is the one that really compares one-to-one to Azure SQL Data Warehouse. So let's go ahead and take a look on this particular guy here, what we find in here. So if I go back in here and browse the other one, which is the dedicated one, I can see I can also have external tables over here. We have that option in there as well. Like if I want to bring data in straight from my T-SQL statements and do the transformations from my T-SQL, I can definitely create external table references from here and bring the data in. But I can also have my data, right, within the service. So, my service is dormant. I think it's paused at the moment. So if I go here into the dedicated one, I see that this particular SQL Pool is paused, you see? So I kind of try to save money between presentations by pausing it. So I'm going to start it again. It's going to take a couple minutes to get started. When it's back up, we will see here that I will have local tables within the storage. And when you create these local tables within the storage, if your background is SQL Server, when you talk SQL Server, you think about, I have a table, and table can be of two types. It can be either a hash table, a heap table, or a column clustered index table, right? So I can have a heap table or a clustered index table. These two types of tables, they define how the data is stored and how SQL Server deal with allocations for the data going into the database. In a similar fashion, we have different types of tables we can create in Synapse as well on the dedicated, right? On the pre-allocated, on the dedicated database instance. But the options we have in there, they're very different from these two we just mentioned. Side note here, by default, a table will be column store indexed, which means it will be compressed at first. So, right, it's by default, that's how a table is created in Synapse. But regardless if it does have a column store index or not, you do have to make a call on how the table will be stored inside Synapse. So I was in this slide here, right? I advanced to this one here by mistake, but this is where we want to be now. The first thing you have to understand about Synapse and how Synapse stores and works with the data is that there is a disconnect in between compute and storage. We just have seen that in the serverless one, where the storage is in the data lake, and it's shared already with whoever has access to the data lake. But in this case here, the storage is kind of in the lake too, but you don't see it. It's a limitless space where you can push all your data in. It's virtually limitless. Microsoft says as you push data, we're allocating more and more data to you, so you don't have to worry about allocating files or anything like that. Just push your data in. But that limitless storage space is organized into 60 distinct, what they called distributions. So that is down here, right? Distributions. So when you create a table, here's the point. When you create a table, that table, depending on the type of the table, but in the majority of the cases, that table, the data of that table will be physically stored and distributed throughout these 60 distribution points that you really don't manage. You don't have to worry about them. You just need to know that the data goes there. And as the data goes in, you can define what's the fashion, how's the algorithm the Synapse will use to put the data in each one of the 60 buckets that comprise and makes up the storage that's going to be used by the computing portion of Synapse. So the first thing to keep in mind, because all of this will be put together in a field, the first thing to keep in mind is my data will be stored in this data storage, and this data storage is organized into 60 distribution nodes, and what they do is they just keep my data. Why 60? Some people ask me. Well, it's a kind of a magic number. There's smart people inside Microsoft, the product team that work with these things. They have done these measurements, years ago, and they came up with this 60. So it's kind of a magic number for them. There are some explanations for this, but they really, I think we should not spend our time in there because we cannot really manage. That's the way it is. So that was the storage. On the other side, what we have on the compute side, what we have is these two elements in here, these two concepts in here. What are the two concepts we have in here? Let me click on this guy here and get my laser pointer so you can follow me along. So what we have in here? What we have is this, and if you have seen a parallel data warehouse from Microsoft before, it was used to be, it still exists, right? It's a product that you can have on premise. It kind of organizes in a very similar way. So you have a control node that, again, you don't see, it's there. You have a control node that's the one that listens to client applications. So when I go to the portal, for instance, and I run that query I just shown you, what is receiving that query from the client application, in this case, the portal, is the control node. This control node will get that query and will dispatch to the compute nodes, which are the actual SQL servers running in parallel to deal with the data. And these compute nodes, they will reach out to the storage, those 60 distribution nodes we have seen. They will reach out to the storage and collect the data from the storage and crunch the data, like if I do a select with a group by, with a where clause, or join tables, all this processing of getting the data together according to my query, they will process that thing, that query in parallel, all of them. crunch the data together, and report back to the control node. So again, we are putting the pieces of the puzzle on the table, right? We get the storage, 60 pieces. We have compute, control node, and we have the compute nodes that actually talk to the distributions to collect the data and put the data together in order to be stitched up by the control node and sent back to the requesting client application. I hope it's clear so far. Okay, so with that in mind, how does that affect my tables? So when before we get there on how specifically the table types will be affected by this, there is one thing, one detail that must be really on the top of your mind when you are make sense of these things. We have compute nodes and we have the distributions, the storage distributions. 60 of them. We always have 60 of them. On the previous slide, let me bring back the previous slide here. I have on this drawing here, which I got from Microsoft websites, from docs.microsoft.com. You know, if you look in there, you're going to find this this particular diagram there. So what we have in here in this example is 4 compute nodes. Why 4? Because this is the one that they use in the design. I could have more or I could have less. And this is defined by the data warehouse units, the DW units, or DW for short, that I associated with my dedicated SQL pool. So if I go back here to the portal, and if I look into this guy here, you can see here that's my SQL dedicated SQL pool. I was there before, right? This is my dedicated SQL pool. And you will see here, again, the dedicated SQL pool. On the right side here, you see that this SQL pool is at the performance level DW100. Is the cheapest one, right? I'm being cheap here. I don't want to run out of my credits during the demonstration. So I got the cheapest one, which is about $1,800 a month if you want to keep this guy running all month long. It's not like I said, it's kind of an expensive service. But this is my performance level, see, DW100. If I go back to my slide deck, I can see that DW100 is right here, right? DW100. It means I have only one compute node. So in the previous slide, you know, that's depicting here 4 compute nodes. For this one, for this particular service level here, what I gotta have is a DW2000. See, a DW2000 is the one that deploys 4 parallel compute nodes to take care of the 60 distributions, right? The storage distributions. Like I told you, it's always 60 storage distributions. So if I have 4 compute nodes, those 60 distributions will be split in 4, right? In a group of 4 pieces. So each one of the compute nodes will be taken care of, will be allocated to work with 15 of those distributions. What's the point here? Pay close attention. You're always going to have parallelism in Synapse. But if you have only one compute node, you know, it's kind of having one physical CPU and 2 virtual CPUs inside the laptop, for instance, right? When you do multi-threading and things like that. So you have one compute node, you have parallel processing that compute node, but within that compute node, it's not really physical parallel processing. When you start going from DW1000 and up, you are actually adding more servers, and therefore adding memory and adding, you know, all the hardware that goes behind the scenes under Synapse. You start adding more resources, which means you have way more horsepower and parallelism degrees going on behind the scenes, right? So you really benefit in Synapse when you get from DW1000 and up, right? Below 1000, it's usually for testing, or in this case, demonstrations in here, or when you want to make something kind of available, but at the same time, kind of a dormant. But again, you're being charged by compute as, you know, even if you leave it in 100 DW100. So here's a very important thing, right? In order to have those 4 compute nodes that I showed before, you have to work on DW2000, specifically the DW2000 in here. And then you get into the tables. And when you get to the tables in Synapse on a dedicated SQL pool, you see, very specific. You are in Synapse, and you are on a SQL pool, and you are on a dedicated SQL pool. So when you are working on this particular environment, not in the Spark or on the serverless, but this particular one, you can make you gotta have to make, right? It's something you have to do. You gotta when you create the table, you have to choose if your table is going to be from the round robin type, the hash distributed type, or the replicated type. What does that mean? How does this affect how SQL Server works? Or rather say, how does it affect how Synapse works? And it affects in this way. If when data is going into the distributions, the data has to be stored. How is the data going to be placed in each one of those 6 distributions? And you may be guessing at this point, right? If you do round robin, you know that the data will be saved in one bucket at a time. So distribution 1, we get a portion of the data. Distribution 2, the next portion of the data that comes in, 3 and 4. So it's kind of a broadcast. It's kind of evenly distributed and tries to balance the whole thing into the storage, which seems like a nice idea. On the other hand, on the hash distributed one, what we have is we're going to define a column, a particular column in the table that will work as the hash distribution column. And SQL Server will apply a hash algorithm on top of that, the values coming into that column, to decide in which distribution, which one of the 6 distributions that the data from that the data coming to that table based on the value of that column will be placed. So you may be ending up with a not so balanced distribution around, but the data will be clustered together by similarity through the hash distributed environment, or the hash distributed algorithm into a particular column. The last one, the replicated one, is a particular case that will make sense when you go into the table design. But what the replicated one does, I'm going to switch back here a couple of slides. What the replication one does is, instead of keeping the data of that table into the storage, it keeps the data into the compute nodes. And there is a special reason for that, which we'll investigate as we move on. So again, when you create the table, you're going to make the call. Is it going to be round robin? Is it going to be hash distributed? Or is it going to be replicated? I'm going to color code these ones in here on the slide so we can see where those tables land into the diagram I have just reviewed with you. And it looks like this, right? This is the diagram. And the round robin and the hash distributed, they live always in the storage place in the 60 distributions, while the replicated ones, they live in the compute nodes. And this is the reason they are called replicated, because the same table is copied over, right? It is broadcast over, is copied over to all compute nodes. There is a copy of that table on each compute node. And why is that? Why do I keep tables on the compute node, and why do I keep tables in the storage place, in the distributions? Couldn't they all be on the compute nodes or all be on the on the distributions? Well, side note here, the replicated one, as a matter of fact, they are really persisted into the distributions. But because they are replicated, when you query them, SQL Server copies that data into the compute nodes, so it can help query situations and joins and things like that. So this is the point where everything is going to converge together. So I hope up to here you are following me along with the pieces of the puzzle we are working on, right? Again, we are working on a dedicated SQL pool in Azure Synapse, and we are working with tables that go into the distribution storage of that dedicated SQL pool, right? They are not external tables. So these tables, they will be one of these 3 types in here. Now, you are working with Synapse and you are working in a relational table in a relational environment because you are more likely going to create a data warehouse, right? You're managing a data warehouse. And your data model for data warehouse more likely will be something like a star schema or a snowflake schema, right? Either one. Then usually star schema is better because it requires less joins to do things, but it can be either a star schema or a snowflake schema. So I just went out on the internet, I Googled an image working, asking for, BI data model star schema, and I grabbed this one from the internet. Someone placed it in there. It's just a picture that's in there. And here is a very common design. We have fact table, and we have dimension tables around the fact table, right, defining its granularity. If I am to create in Azure Synapse a database design to store these tables, again, I have to make the call in between which kind of tables these tables will be. And the bottom line is, for my fact tables, because these fact tables, they tend to be really big, what I want to have those fact tables is in the distribution. I want to have those tables in the distribution. And the dimension tables that are usually joined together with the fact tables, I want to have them as replicated tables. And again, side noting here, don't confuse replication here, replicated tables, with the replication system that exists in SQL Server, right? It's just the same name, replicated, but there is nothing to do one with the other, right? Don't confuse both. So I want to have this dimension tables as replicated, as I put the legend here on the slide, right? Replicated and distributed. And why is that? That's because, again, like I said, usually the fact tables are the largest ones. So I want to have the maximum parallelism possible to crunch the data coming from all the tables, all the distributions holding data for that particular table. I want to process them in parallel as much as I can to get to the results of my query as fast as I can, right? So that's why I want to have the fact tables as distributed tables. And I want to have the dimension tables because I want to have the dimension, and by the way, the dimension tables, they tend to be way smaller than a fact table is. Of course, your case could be a little different, but usually the dimension tables are way smaller than the fact tables. So if I keep the dimension tables into the compute nodes, the compute node has everything that it needs to process the data within itself. It has the data coming from the distributions it handles, and it has the dimensions that are already there in the compute. It has a copy of the dimensions for itself in the compute. So if you follow this simple guidance, you're going to get one of the best database engines out there with top performance. Of course, there are other things you have to consider. You have to make sure you got a good hash, a good column as your hash column, to make sure you don't have much skew. Like if one of the distributions is processing 15 million rows and the other distribution is processing 2 billion with a B, 2 billion rows, your execution time will be the slowest one of your distributions, right? Of your compute nodes. And therefore the one that has more data. So you don't want to have much skewing there. You want to have them kind of a balanced out. But if you do round robin, you kind of achieve that, but you end up in a other situation that will crush your performance. It will be really bad for your performance. What other situation is that? It's this one here. Heading to close out our session here. Again, I have 4 compute nodes in these examples. I have 60 distributions, which means each one of these compute nodes manage 15 distributions. You probably have noticed here there is this thing called DMS, and DMS stands for Data Movement Service. The bottom line here is when data flows, when the query comes in and the query goes down to the compute nodes request the data from the distributions, Data movement servers, or DMS, is controlling this. It's internal system you don't see, but it's controlling this. And vertical movement of data is great. It's what we should design for. So the query comes in, it will be sent to all. So like if a query comes in and it's asking for data from 2020, how was my sales in 2020? I don't want to have a column that will place all the 2020 data in one compute node. Because if I do, even though I have 4 compute nodes, my query is filtering for a collection of data that's managed by one of the compute nodes only. So the other compute nodes will know, this data is not here, they will be idle, and we will be paying for 4 compute nodes, but only one of them will be busy. And that's not a good idea, right? So you want to have a hash column that will distribute your data in a way that all compute nodes will be busy by collecting data from the distributions they take care of. Again, vertical. And here's the trick. Pay close attention to this one now. When the data comes into the compute node, if the compute node needs data that is in another distribution, that compute node cannot reach out to that distribution. That compute node will communicate horizontally with the other compute nodes requesting the data that was in the other one. So there is a chance, if you don't design it well, there is a chance that horizontal communication will be happening between the compute nodes. When this happens, then your performance is going to go down really bad. So you want to avoid situations when you do a join, like the round robin forces this. That's the problem with the round robin. It gets evenly distributed, but if I do a join here, there is no way that all the data that this compute node is going to work with, there is no way the data will be just in this collection of distributions. We will have to talk to the other guys. So if your table is that big, you don't want to use round robin. If the table is that small, or if you have only one compute node, then it doesn't matter, right? It will work just fine. But if you have more than one compute node, you want to do a hash table, hash table, kind of table in Synapse, and you want to make sure that whatever is needed for a compute node to deal with data when processing your joins, specifically the joins, it will be within the compute node itself. And therefore, having the replicated tables in all compute nodes for the dimension tables will avoid communication in between the compute nodes. And that's why you should have the dimension tables as replicated tables instead of hash distributed tables. And there you have it, right? This is the main goal of this session, is to make sure that you understand that when you design your tables into SQL and you're doing multiple compute nodes, you want your largest tables to be hash distributed tables for the majority of the time, 99% of the time. You want to make sure that when you run queries, you're gonna keep all the compute nodes busy. So you're gonna select a column that will distribute the data in a way that all compute nodes will always be requested to process your data. And you're going to keep your data movement on a vertical fashion, not on a horizontal fashion, which is in between compute nodes, right? So to summarize it and wrap up the session, these are the type of tables. And a table is not just a table. It has all of these intricacies involved to it. And just creating a table will not do the trick. You really have to put your brains on and choose the right table for the right application. You have external tables when the data lives in the lake. You have replicated tables for the tables you want to keep in the compute nodes. And usually the dimension tables are the best candidates for these ones. You have the hash distributed tables. That's the one that will give you the best performance, especially when you have more than one compute node for your particular dedicated performance level. And you have the round robin distributed ones that will give you evenly distributed data in between the distributions, but may hurt you when you are processing data in parallel in multiple compute nodes, all right? I hope that that was good information for you. I hope you can benefit from this information. And if you have any questions later down the road, if you want to connect with me in LinkedIn and have the conversation going on in there, you are welcome. I usually love to have questions and discuss questions. I am also in Stack Overflow, so they have a hashtag there for Synapse. So if you want to post questions, then Stack Overflow is even better because you can have the group collection of wisdom there on your particular case. And I see you in the social medias, all right? Enjoy the rest of your Sunday. I hope you're enjoying the conference. And I see you. See you later. Bye-bye.